Here in this chapter, and this is really the last of the trig-intensive chapters, we start looking at some of the applications of trig functions. So we've done a lot with the basics of trig functions, unit circles, then we got into all the proofs and formulas that involve trig functions and solving trig equations, and now we're going to use some of that information to find sides and angle measures for triangles that are not right triangles, which is very different from what we've done before, and then also to work with vectors. So law of sines and law of cosines are two methods for finding missing sides and angles of triangles. When you worked with right triangle trig, either earlier in this course or in previous courses, you worked with SOHCAHTOA, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, etc. But what happens if it's not a right triangle, right? Not to be silly, but right triangle trig only works for right triangles. Clearly, not every triangle is a right triangle. So how do we work with non-right triangles? Well, let's look at the area of a triangle. Okay, basic information about area of a triangle. If this thing is a right angle, remember the height of a triangle goes from the vertex perpendicular to the base. If we know how to find the area of a triangle is 1/2 base times height. So here's the base, here's the height, 1/2 base times height. So if you have two sides in the included angle, you can find the area of any triangle. How do we do that? Well, look at this angle over here. I can create myself a right triangle by using this as the height, that is the base, and that is the hypotenuse. So the sine of angle C is opposite over hypotenuse. So the opposite side is h, the hypotenuse is a, so sine of C is h over a. Now multiply both sides by a. All right, so a sine C can replace the height. And so we get a formula that says the area of a triangle is 1/2 AB times the sine of C. Now look where that is in the triangle that we have over here. Notice that the lowercase letters represent the sides of the triangle. The uppercase letters represent the angles of the triangle. So A and B are the two sides of the triangle. C is the angle of the triangle. It has to be an angle, right? You can't take the sine of a side. So you've got two sides in the included angle. So if you have a case of side, angle, side, yes, this really is like geometry, side, angle, side. Two sides in the included angle, meaning the angle that's in between those two sides. That's how you can find the area of a triangle, 1/2 AB sine C. So the question says, find the area of a triangle with sides 4, 9, and an included angle of 47 degrees. This one doesn't give us any units for the 4 and the 9, but that's okay. So here's a side of 4. Here's a side of length 9. It says the included angle is 47 degrees. So this angle here, 47 degrees. Formula, area equals 1/2 side times the sine of the angle between them. So in this case, our two sides are 4 and 9. And then the angle measure is 47 degrees. So we've got to work our way and find the sine of 47 degrees. So grab a calculator, make sure it's in degree mode because we're going back to degrees for a little bit. So you get 1/2 times 4 is just 2, times 9 is 18, times the sine of 47. Right, I get 13.16. 13.16 what? Well, I don't have anything else to call it, so I'll just call it square units. Right? Side lengths are measured in linear units, area is measured in square units. This gives me 13.16 square units. So that's one of the things I can do, is I can find the area of a non-right triangle. So here's the law of sine. Let's go back to that triangle that I had drawn before. And we had said that if I had block off just part of this, because remember that the height is always perpendicular to the base. So base and height are perpendicular. So this is perpendicular, which means it forms two right triangles. One of them on the right-hand side over here. Right? And so the sine of angle C equals opposite over hypotenuse, h over a. But we could also come over to the other side. We could look at the angle over here and say the sine of angle A equals h over c. Right? Multiply both sides by the denominators of each one, and you end up with a sine c for the height on one side and c sine a for the height on the other side. But you realize that that height is a common segment between both triangles. So those heights must be equal to each other. So we can set them equal to each other. we can then separate them into a proportion. So the proportion looks like this. It says the sine of angle A over side A equals the sine of angle C over side C. Now, if you were to cross multiply, right, sine of A times C, that's this side over here, A times the sine of C, that's this side over here, okay? So when you separate them, you create a proportion. You can eliminate the proportion by cross multiplying and you'll get back to where you started. So for any triangle ABC, this statement is true. The sine of an angle over its opposite side equals the sine of an angle over its opposite side equals the sine of an angle over its opposite side. So this is called law of sines. There are two cases for which we're going to use the law of sines because we have to have 3 of the 4 pieces of information. In other words, you wouldn't use this whole thing, like all 3 parts. You would just use 2 parts. So you would say like sine of A over A equals sine of B over B. Or sine of B over B equals sine of C over C. Which means that out of these 4 things, meaning angle A, angle B, side A, side B, you have to have 3 of those 4 things, otherwise you can't find the 4th one. If you only have 2 of those 4, law of sines isn't going to work. Which means that there's 2 cases where this will work. One of those cases is the case of what we call angle-angle side. So angle-angle side, just in sort of generic drawing sense, is 2 angles and a non-included side. So 2 angles and a side that's not included between the 2. So 2 angles and a side that's not included between the 2. If it was included, it would be angle, side, angle. They actually go in order, right? Angle, angle, and a side not between them. So here's a question. It says solve triangle ABC given an angle measure, another angle measure, and a side. Now when it says solve the triangle, that means give all the sides and angles that are not given in the triangle. So what's not given is angle C, side B, and side C. So let's draw ourselves a picture. It doesn't have to be a perfect picture. It can kind of be a generic picture. So triangle A, B, C. Angle A is 36. Angle B is 48. And side A. So if angle A is up at the top, side A is down there. So what do I know? I know the sine of angle A, so the sine of 36 over 8 equals the sine of 48 over the side opposite 48. So the side opposite 48 we'll call B. Because if the 48 degree angle is the measure of angle B, then side B is opposite angle B. All right, and then we cross multiply. So 8 times the sine of 48 degrees equals B times the sine of 36 degrees. And divide both sides by the sine of 36. All right, the sine of 36 is cancel. And now I just have to be careful, right? If your calculator uses parentheses, you might need to put a set of parentheses around that or a set of parentheses around the whole top in order to make it not take 48 degrees and divide it by the sine of 36. All right, you try it, I'll try it, we'll reconnect in a couple of seconds. All right, I got 10.11. So 10.11 is the length of side B. Now, I can find angle C actually without using any fancy formulas. Just do 180 minus the other 2 angles. Because I know that angles A, B, and C have to add up to 180. So the measure of angle C is just 180 minus 36 minus 48. 96 degrees. So clearly my picture is not drawn to scale. Right, and then we got 10.11 for this. And the only thing left now we have to do is find side C. So over here, that's side C because it's opposite angle C. We can use the law of sines again. So pick either of the 2 measures. I'm going to start with the original one. So I'm going to go back to the sine of 36 over 8. So sine of the angle over opposite side equals sine of the angle over opposite side. Right, so 8 times the sine of 96 degrees equals c times the sine of 36 degrees, and divide both sides by the sine of 36. And so the sine of 36 is canceled top and bottom, and what we end up for side c, let's each work on it, and we'll compare. Right, I get 13.54. Now, is there a way to absolutely check your work just by looking at it? No, but there is a little quick check that you can do to see if things make sense. In a triangle, the longest side is opposite the biggest angle. The shortest one's opposite the shortest angle. So, look at angle A. Angle A is the smallest of the three angles. The side opposite angle A is the shortest of the three sides. The 48-degree angle is the one in the middle, so its opposite side is 10.11. Angle C is the largest, side C is the longest. So we can at least see that it works correctly in that the shortest side, smallest angle are opposite each other. Longest side, largest angle are opposite each other. So I can't guarantee that the 13.54 is correct by looking at it, but at least looking at my triangle, it gives me some reasonable assurance that at least things are going in the right order. So that's a simple case. Angle, angle, side, sine of the angle over opposite side, sine of the angle over opposite side. Now, the other case for law of sines is an ambiguous case we call side-side angle. Yes, you can reverse the letters, but we'll go with side-side angle. So we can also use two sides and a non-included angle. So what does two sides and a non-included angle look like? If I draw out a generic triangle, two sides and a non-included angle. Right? So there's a case of two sides and a non-included angle. It's called the ambiguous case because the information we have might describe one triangle, two triangles, or maybe no triangle at all. Right? Just the given information may not determine a triangle. So look at this case. Measure of angle C is 33 degrees. I know the side of AC, and I know the side of AB. But without that angle in between anchoring that third side, that red segment that you see in the slide here, I don't know whether that segment comes down here, right, and forms an obtuse angle down here, or comes out here and puts the wider angle at the top and the smaller angle at the bottom. So it's like there's a hinge here where it moves back and forth. That 6-inch piece could come down here and create one triangle, or it could swing out and make the other triangle. So that length BC could be many different lengths depending whether it's on the inside here, on the outside there, or somewhere in between. So what do we do? Well, let's look at a couple of cases here. It says solve triangle ABC if the measure of angle A is 30, side A is 5, and the length of B is 8. All right, so the first thing is let's draw ourselves a picture. Usually a good way to start. Measure of angle A is 30. Side A is opposite angle A, so that's 5. I'll put B up here. Side B is 8. This is C. Okay, so in this case, I've got two sides and an angle. In the other cases, I had two angles and a side. Well, I know I've got the sine of 30. Sine of 30 over 5 equals, let's go with the sine of B since that's the only other piece of information I can work with. Because I've got the opposite side, I just don't have the angle measure. All right, so cross multiply. 5 times the sine of B equals 8 times the sine of 30. All right, what's the sine of 30 degrees? Right, sine of 30 is the first entry in the first quadrant, so it's the y value, so it's a half, which gives me 8 times 1/2, which is 4. So I get 5 times the sine of B is equal to 4. Divide both sides by 5. And I get the sine of angle B equals 4/5. So now if I want to find the measure of angle B, I got to take the inverse sine. So the measure of angle B equals the inverse sine of 4/5. Go to my calculator and find the inverse sine of 4/5. I get 53.13 degrees. Now, that's true, right? The measure of angle B can be 53.13. But remember that sine is positive in the first and second quadrant. So if I've got an angle measure up here that's 53.13 degrees and produces a y value of 4/5, somewhere on the other side of the y-axis is another angle that does the same thing, that has a 53-degree reference angle with in this case, the negative x-axis. So what is that angle? Well, that angle must be the whole thing except for that 53 degrees. So it's all of 180 except for that 53.13 degrees. So another possibility in quadrant 2 is that the measure of angle B is 180 minus 53.13 degrees. And what is that? Let's find out. 126.87. All right, so now we've got ourselves two triangles. That's what this case is. So we've got triangle number 1 and triangle number 2. So here, let's separate them. So triangle number 1. The measure of B is 53.13, which means that the measure of C is 180 minus 30 minus 53.13. So 180 minus the 30 that was given minus the 53.13 that I found is 96.87. All right, so that means that the only thing left I have to do is I have to find side C. Side C is this one over here. So I can set up the sine of 30 over 5 equals the sine of 96.87 over C. And so we do 5 times the sine of 96.87. And then divide it by the sine of 30, which is a half. And I get 9.93. So side C is 9.93 units. All right, the other option, triangle number 2, is that the measure of angle B is 126.87. And so now the measure of angle C is going to be much smaller. It's going to be 180 minus 126.87 minus 30. That gives me 23.13. And now I've got to see whether this produces a valid triangle. So we'll do the same thing. We'll do the sine of 30 over 5 equals the sine of 23.13 over C. All right, so again, 5 times the sine of 23.13, and then divided by the sine of 30, which is a half, I get 3.93. So you can see the measures are very different. That's because the angles are very different. So one option is that the side C is very long and angle C is very big, right? Angle C would be 97 degrees. The side of C would be almost 10. The other option is that this angle here is much smaller. It's only 23 degrees, and the opposite side is 3.93. So when I solve this, I actually end up with two triangles, and that's one of the possibilities because of that ambiguous case. That 30-degree angle is not enough for me to figure out whether the angle at C opens widely or not. All right, let's look at the other two possibilities. All right, similar idea. What if the measure of angle A is 30? Side A is 3. Side B is 8. So again, let's try to find information about missing angles and missing sides. So I've got the sine of 30 over 3 equals the sine of B over 8. So again, to set these up, I have to have 3 of the 4 parts. So I have to have an angle and a side, and then either an angle or an opposite side. All right, so I get 8 times the sine of 30, which is a half, equals 3 times the sine of B. So 4 equals 3 sine B. Divide both sides by 3. Something happens here. We get 4/3 as the sine of angle B. Now remember that the sine values can't be any bigger than 1. Can't be any smaller than -1. Which means that this doesn't produce a valid thing. There is no such thing as the sine of an angle being 4/3. So it does not exist. Which means there's no triangle. Which means that whoever designed this problem gave you side lengths and angle measures that don't form a triangle. In order for that angle to exist, the sine would have to be 4/3, and it doesn't happen, so it doesn't exist. So that's another possibility. 2 sides and a non-included angle, right? Angle or side-side angle, can produce no triangle. All right, similar problem. Notice I just changed a couple of numbers around. Measure of angle A is 30, and I gave you 2 other sides. So let's draw this picture out. Measure of angle A is 30. Side A is 9. There's the angle B. That's 8. Here's angle C. I don't know what that is. So I get the sine of angle A over A equals, should be a lowercase a. Sine of A over A equals sine of B over B. So the sine of A is the sine of 30, which is a half, over 9 equals, I don't know what the sine of B is because I don't know what angle B is, so that's my variable, over 8. So 8 times a half is 4 equals 9 times the sine of B. Divide both sides by 9. 4/9 is sine B. So it looks like now I've got a sine that's positive, and sine is positive in both the first and the second quadrant. So let's see if I get 2 cases here. So the measure of angle B must be the inverse sine of 4/9. Grab a calculator. Inverse sine 4/9 is 26.39 degrees. All right, so remember we said that the reference angle on the second quadrant is also 26.39. So this is option 1. Option 2 is that the measure of angle B is 180 minus 26.39. All right, so let's do that. Let's take 180 minus 26.39, and I get 153.61. Okay, here we run into a problem, and here's the problem. If I now said go ahead and find the measure of angle C, the measure of angle C would end up being negative, because here you've got 153.61. You've already got a 30-degree angle in there. So if you add those two together, they add up to be more than 180. Right? Adding up the 2 angles that you found, the 153.61 plus 30, gives me 183.61, and that doesn't even include the third angle. So the only way you would get it to add up to 180 is if the angle C was negative 3.61, and that doesn't work. So that is not a valid angle measure. The only one that's going to work is that 26.39. Right, so we can finish the problem using just the 26.39. That the measure of angle B, 26.39. The measure of angle C then must be 180 minus that. So 180 minus 26.39 minus the 30 that was also given to us, 123.61. And now I can find side C. So I can do sine 30 over 9 equals sine of 123.61 over C. And now I've got everything I need except that one side. So I'm going to do 9 times the sine of 123.61. And then take that and divide it by the sine of 30. Gives me 14.99. So the only way this triangle exists is with a very large angle C and a very small angle B. So this is 123.6, and this is 26.4. And that very large 123-degree angle produces a side here that's very close to 15. All right, this is getting long, so I'm going to do the last couple of examples, and we'll recap the procedure in the next video.